Hello, everyone, and welcome to our webinar on the quantitative results chapter. And just before we start with the presentation today, I would like to present this information in case you are interested in additional support outside of this webinar. So we do provide assistance with all aspects of the dissertation. And if you are interested in more one-on-one support or assistance, you can contact us using this information to learn more about the types of assistance that we provide. And before we get into the presentation, I'll just give a little overview of what we're going to be covering today. So this presentation is going to be on the quantitative results chapter. So we won't be discussing mixed methods or qualitative today. We'll just be focusing on quantitative. And we'll start with the purpose of the results chapter, and then we'll talk about the different components that should be included in the results chapter, including an introduction, the data collection and preparation, descriptive statistics, assumptions testing, testing of the research questions. And then at the end of the presentation, we'll have time to answer questions. So if you do have questions during the presentation, you can type those into the questions section. And any questions that aren't answered over the course of the presentation, we'll have time at the end to answer those specific questions. So first, let's talk about what the purpose of the results chapter is and why the results chapter is important. So the purpose of the results chapter is to present the data and analyses that were conducted to answer the research questions. So in the previous chapters of your dissertation, you are establishing why you need to conduct the research and how you're conducting the research. When you get to the results chapter, you're finally presenting the results of that research or what you found. You're just presenting the answers to the research questions and hypotheses. And you want to present the appropriate statistical findings for each research question and hypothesis, along with a clear statement that answers each research question and hypothesis. So by the end of the results chapter, you should have a clear answer to each research question and hypothesis that you have proposed in your study. But you shouldn't go too much more beyond answering those research questions and hypotheses. You want to save further interpretation for the discussion chapter. So the results chapter is not the place for talking about other literature and how your results relate to the literature or what your results mean for the field. You save that for the discussion chapter. In the results chapter, you're just providing an answer to each research question and hypothesis. And although today we'll be covering the sections that are most commonly required in the quantitative results chapter, you do want to make sure that you always refer to the specific guidelines or requirements of your school or degree program to make sure that you include all of the necessary sections. So we'll be talking about what's typical based on our experience, but your school may have different requirements. They may require more sections, or they may require fewer sections. They may require the sections to be organized slightly differently. So you always want to make sure that you defer to your school's guidelines when constructing your results chapter. So now let's get into the components of the chapter. And it starts off typically with an introduction, like most other chapters in the dissertation. And in the introduction, you just want to restate the purpose of your study and your research questions and hypotheses, just to reorient your reader to the objectives of the study. And then you can just outline the contents of the results chapter. And this can just be as simple as listing out all of the section headings that will appear in the chapter. So the introduction is just really brief. It doesn't have to be a whole lot of detail. It's really just restating purpose, research questions, and letting the reader know what to expect in the chapter. And next typically comes information about the data collection and preparation. So here you want to really summarize the results of your data collection procedures and your procedures for preparing the data for analysis. So you want to summarize what you did in the data collection and importantly, note any changes that you encountered from the originally proposed procedures. And different schools will have different requirements for how to deal with changes from your proposal. So you might run into the situation where you proposed um, certain data collection procedures in your methodology chapter, but for one reason or another, you may have had to make some changes to those procedures between when you did your proposal and when you actually finished collecting your data and got to your results chapter. So if there were any changes to the procedures that you outlined in your proposal, you want to note what those changes were in your results chapter. And sometimes schools will even want you to go back to your methodology chapter and update the methodology chapter to reflect the changes that you had to make, to reflect the actual procedures that you carried out. Other schools want you to leave the methodology chapter as is and just explain in the results chapter anything that you did differently from what you originally proposed. But you do want to make sure that any changes that you have to make to the procedures are made clear in one way or another. You want to discuss the results of your data collection in terms of the response rate and attrition. So this includes information such as, how many total responses did you receive, or how many total people were entered into the study. So for instance, if you're doing a survey study, how many people in total responded to your survey? And then you want to talk about if you had to remove any participants or responses. So did you have to exclude anyone? For what reasons would you have to exclude people? How many people did you have to exclude, and what reasons were there for excluding those people? Then after discussing that attrition and removing participants for various reasons, you want to state what your final total sample size was. And if your final total sample size did not meet the target sample size that you set out in your proposal, which typically you would determine using a power analysis, then you may want to, or you may be required to conduct a post hoc power analysis to report the statistical power of your test with the sample that you obtained. Some schools may not require this, but some schools do. Again, it depends on your specific school's requirements. And in terms of the post hoc power analysis, we won't go into a lot of detail on how to do that in this presentation, but we do have other webinars that are specifically dedicated to power analysis if you want to know more about sample size calculation and post hoc power analysis. And then after you talk about the sample size, you want to discuss preliminary data preparation steps. So this may involve checking data for accuracy, handling missing data, and checking data for outliers. And it may also include information about coding or recoding data or computing scores for your variables. So especially if you're doing a survey study and you had people fill out paper and pencil surveys and you had to manually enter in those paper and pencil responses into an electronic spreadsheet, it's important to check that data for accuracy to make sure that you don't have any data entry errors. It's also very likely that you'll have, to some degree, missing responses in your data, and you want to describe in detail how you're handling those responses. So whether you're just excluding people who are missing any data, if you are keeping some people who are missing data, how are you handling those missing responses? Are you doing some kind of imputation or replacement? You want to describe those procedures. And you want to describe the different coding that you'll be doing for your data as required. So if you're using survey instruments, then how are you going to code those survey instruments? How do you compute scores for those survey instruments? You want to describe that process. So here are just a couple of examples of how you might write up this information about the data collection and preparation. So here we just have a little excerpt of an example where we say, what our total number of survey responses was. We talk about how we exclude participants who were missing data. We talk about our final total sample size. And then we talk about how we're dealing with missing responses, in this case, saying that we're doing an imputation. And here's another example where we talk about the time frame of the data collection, total number of participants, and then we talk about a lot of information about how we excluded certain participants. And then we talk about missing data, and we talk about the final total sample size. And then here's just a small excerpt that's an example of how you might write up a post hoc power analysis. So we talk about the specific type of test that we did, the number of participants we had for that test, and the power level that we achieved for that test. So that's just an example of a post hoc power analysis write-up. It doesn't have to be incredibly long. It just really needs information about the final sample size and the level of power that you obtained for each statistical test. So next, let's go into the descriptive statistics and the demographics. So after you go through all the data preparation, you can start getting into these descriptives. So you want to present descriptive statistics for all of your demographic variables and all of the variables of interest, so the different variables in your research questions. So you might present frequencies and percentages for things like categorical variables. So that would include things like gender or ethnicity, and means and standard deviations for continuous variables, which would be something like age in years or grade point average or income in dollars. And if possible, you may want to compare the demographic characteristics of your sample to the population. There are some schools that require this information in the results section. So if you do have demographic information from the population, you can compare your demographic characteristics in your sample to see how close your sample represented the greater population. So for instance, you might have a population that is 60% female and 40% male. You want to report the percentages of males and females in your study and see if that is close to that 40-60 split that you see in the population. And in the descriptive section, you may also need to present reliability coefficients such as Cronbach's alpha for measures if applicable. So this really applies if you're using a type of survey instrument where you have multiple items measuring some kind of a construct, and you may need to report the inter-item reliability of those measures or survey items, and that's typically done with something like a Cronbach's alpha. And so here are just a few examples of how you might present descriptive statistics in your results chapter. So you see here that we have both a little bit of narrative and a table to present our frequencies and percentages for our demographic information. And one thing that's important to note throughout the results chapter is that every time you have a table in the results, you will need at least some narrative to describe that table. So you don't just want to present a table by itself with no description or explanation of that table. Every table does need some kind of explanation in the text. And you see here that in the text, we specifically cite or refer to the table. So you want to make sure that every table is referred to in the text specifically. And you want to make sure that the first time a table appears in the text, it appears near where it is first cited, typically above or below the first paragraph when you mention the table. So for instance, you don't want to, in your narrative, say, you know, these are the descriptives that are presented in table 1, and then table 1 doesn't appear until 10 pages later. The table should appear very close to where you reference it in the text. Then here's another example of a table, this time showing descriptive statistics for continuous variables such as age. And we see that here we have means and standard deviations, as well as minimum and maximum values. So that's just an example for continuous variables. And then here's an example of reporting reliability or Cronbach's alpha for different measures if this applies to your study. So we have a little bit of narrative describing up here, and then we also have a table showing all of our Cronbach's alpha coefficients. So after you've gone through all of your descriptive statistics, it's time to start talking about the analyses that you're going to be conducting or did conduct to answer your research questions and hypotheses. But typically, most statistical analyses are going to require statistical assumptions tests, and you want to present the results of the assumptions testing in your results chapter. And sometimes schools will want you to present this in a standalone section before you present the main results, or sometimes schools will just want you to present the results of the assumptions testing alongside each analysis. So again, refer to your specific school guidelines in terms of how to organize that information. But for the assumptions testing, you want to list and discuss the required assumptions tests for each analysis that you are conducting. So for instance, for something like an independent samples t-test, you may need to test the assumptions of normality and homogeneity of variance. And so for each analysis that you're doing, you want to list each assumptions test. You want to talk about how each assumption is tested. So for instance, with normality, are you using something like a Shapiro-Wilk test? Are you looking at skewness and kurtosis values? Are you looking at a graphical representation of normality, such as a histogram? Or are you using a combination of those methods? You want to state how you are testing that assumption. You want to clearly state the result of that assumptions test. So a clear statement or presentation of statistics for that assumptions test. So if you're doing a Shapiro-Wilk test for normality, you want to present the p-value for that test. If you're using a histogram, you want to include the histogram in your results document as a figure. And then you want a clear statement of whether each assumption was met or was not met. So by the end of this, you should say, you know, the assumption of normality was met or the assumption of normality was not met. It should be made as a very clear statement. And then if the assumption was not met, you want to discuss any actions you took to account for the fact that that assumption was not met. So if you had the assumption of normality violated, then maybe you did a non-parametric test or some kind of transformation to the data to account for the normality assumption. And like I mentioned before, the assumptions can be presented alongside each analysis or in its own dedicated section, depending on what your school requires. So now let's just look at some examples of how we might present the results of assumptions testing. So here's just a basic figure for testing normality using a normal PP plot. You see we have some narrative up here to describe how we tested normality. We describe the results of that normality test, which is our interpretation of the figure here. We see that we don't have any real deviation from the normal line, so we can say that the assumption of normality is met, and we indicate that in our narrative. And then here is just a narrative explanation of some other assumptions tests. We say how we're testing the assumptions. We say whether the assumptions were met. And in this case, we have um, an example of when an assumption was not met. So we detected outliers in our data, and we specifically say how we're dealing with that outlier, saying that we excluded it from the analysis. Then after we discuss all the assumptions, we can finally get into the actual results for the research questions and the hypotheses. So you want to present in order the results of the analysis conducted to address each research question and or hypothesis. And you want to organize this section by research question or by hypothesis. Just do it in the order in which they're presented throughout the rest of your paper, because it may confuse the reader if you kind of jump around to different research questions or hypotheses in some kind of a different order. So if you have 5 research questions, it makes sense to just go research question 1, then research question 2, and so on. You don't want to start with, research question 2 and then jump to research question 5 or anything strange like that. It just may confuse your reader. So you want to present it in a logical order. And like the data collection procedures, if there are any changes from your originally proposed data analysis plan, you want to note those in your results section. Again, some schools may require you to actually go back to your methodology chapter to change that chapter to reflect what you actually did. But other schools will want you to keep your original procedures in place. And then when you get to the results chapter, explain if there were any changes, why you made those changes, and provide justification for the analysis that you actually ended up conducting. And for each analysis, you want to clearly identify the variables that you use. So for instance, identify all of your independent variables, dependent variables, predictor, criterion variables, covariates or control variables. You want to clearly state what those are for each analysis. You want to report the appropriate statistics associated with each analysis. So this would include the statistics for each test. So, if you're doing a t-test, you want to present the t-statistic. If you're doing an ANOVA or an f-test, present the f-statistic. For each test, you obviously want to present the p-value, which is the main thing that you'll interpret to determine if a test is significant or not. And you will also be expected to include effect sizes, so and maybe confidence intervals. So for a t-test, you might include Cohen's d as an effect size. For a regression, you might include an r squared or standardized regression coefficients for an effect size, or confidence intervals for any of those estimates. And if you're doing an analysis that requires post hoc testing, such as an ANOVA, then you want to also report the results of those post hoc tests. And then for each analysis that you're conducting, you want to include a clear statement that answers each research question or hypothesis based on the results of the analysis. So you want to make it very clear for each hypothesis. If you're presenting them in null and alternative format, say whether the null hypothesis was rejected or whether the null hypothesis was not rejected, and also explain how you arrived at that conclusion. So this would typically mean, the p-value for your test was above or below 0.05, and that's how you'd make the determination to reject or not reject the null hypothesis. You just want to make that as a very clear statement in your results chapter. But again, don't really go into interpretation too much farther beyond that. You just want to present enough to answer or address each research question and hypothesis. So let's go through some examples of how you might present the results of different analyses. And we can start with something basic like a t-test here. So you see here that we have some narrative describing what test we conducted, an independent samples t-test. We identify our variables, our independent variable and our dependent variable. We present the results of our t-test, so all of the statistics that we need for our t-test, such as our t-statistic with our degrees of freedom in parentheses, our p-value and our effect size here. And we state a clear statement here that the null hypothesis was not rejected because our p-value here was greater than 0.05. And then we have, if applicable, you can have a table to present the results. So this is just a basic example for the results of a t-test. Now here's another example of a t-test, but this time we have significant results. But you see again, we state what test we're doing. We state our independent and dependent variables. We state the statistics for our test. At this time it is significant. And then we have a statement here, the null hypothesis was rejected. And here's an example of an analysis of variance or an ANOVA. And again, we present information about our independent and dependent variables. We present the results of our ANOVA, so our F statistic with our degrees of freedom in parentheses, our p-value. In this case, we have a test that is not significant, so we say the null hypothesis was not rejected. And we have a table showing the descriptive statistics for the means that we are comparing with the ANOVA. And then here's an example of a result for some Pearson correlations. So in this case, we're actually, restating our research question, saying that we're conducting the Pearson correlation, stating the variables that we are using, and then we present the results for our correlation coefficients with our p-values here. And you may also have especially if you have a lot of correlations, maybe a table down here to show the different correlation coefficients that you're testing. And then again, a clear statement for our hypothesis, in this case saying our null hypothesis was rejected. So we had significant correlations. And now here's an example for a multiple linear regression. So you might have the results of your f-test for the linear regression for the overall model. So report the results of your f-test, your p-value, and your r-squared for that regression model. And then you may talk about your individual regression coefficients or present them in a table. Talk about which predictors were significant. And again, in here, since we have a significant overall regression model, we have a statement for our hypothesis. The null hypothesis was rejected. And then finally, after you present all of the results for each of the research questions and hypotheses, you can end your results chapter with a summary. And this is usually just a summary of the chapter contents or just a summary of the findings for each of the research questions. So you want to restate the answer to each of the research questions and hypotheses. If you have hypotheses in null and alternative format, restate whether each null hypothesis was rejected or not rejected, and then provide some kind of transition to your discussion chapter. You can say something like, in the next chapter, we'll discuss these findings and directions for future research. So just want to provide that transition into chapter 5. And so that brings us to the end of the presentation. So that covers all of the different components of the results chapter. And again, if you are interested in additional support outside of these webinars, you can use the information here to contact us to learn more about the different help or services that we provide. And with that, we can get to the question section. So if you do have any questions, you can go ahead and enter those into the question section now, and I'll do my best to answer your questions. And it looks like I don't currently have any questions in the queue right now, but I'll just wait for a minute or two to see if anyone wants to type in a question. So if you do have a question, you can go ahead and enter that in now. Okay, so I have a question here. Does a Cronbach alpha have to be calculated from the collected data, or the alpha of the data measurement tool suffices? This will depend on what specifically your school wants, because if you're using an instrument that has already been validated, you may not have to do your own computation for Cronbach's alpha, although it is common to do so. Um, so some schools may want you to calculate the Cronbach's alpha so you can see how reliable the instrument was with your collected data. Other schools may not require that. And usually if the school doesn't require you to do your own Cronbach's alpha computation, you would usually just present that reliability information in the methodology chapter when you discuss the reliability and validity of the instruments that you're using. But the kind of the short answer is it is common to do your own Cronbach's alpha computation, even if there are statistics available in the data, or in previous data rather. And a question is, do you provide advice on results to be presented for SEM results? For structural equation modeling, that's more of an advanced analysis, so it is a little bit more involved. So for structural equation modeling, what you would typically do is first establish a measurement model, or in other words, a confirmatory factor analysis, where you just have a measurement model with all of your constructs. You don't draw all of your structural paths yet. You establish, the loadings and the fit of the model for just the measurement model, and then you provide results for your structural model. So then you run your model with all of your path arrows drawn, and then you might have hypotheses for specific paths that you have in your structural equation model. So for instance, you might have a hypothesis that one variable in your model is related to another variable, and you might have several hypotheses like that. And really, you just want to go through each of the hypotheses and state whether those paths were significant and whether you accept or reject the null hypothesis for each of those specific paths. And for structural equation modeling, like I mentioned before, with establishing your measurement model and model fit, so that'll be another part of the output that you'll typically have. So you'll have fit statistics such as the CFI or RMSEA or any number of other fit statistics that you'll present for both your measurement model and your structural model, in addition to the actual path coefficients that you're testing, which would presumably be related to your hypotheses. So those are the types of things that you might include if you are writing up the results for a structural equation model. So another question is, how should one go about accepting or rejecting the null hypothesis? So that goes back to if you're doing hypotheses in the null and alternative format, and typically the logic behind these statistical tests are based on this null hypothesis testing, where you look at the p-value or the significance value for the test to determine if it is significant or not. So that p-value that you get from your t-test or your ANOVA presents the probability of getting a type 1 error or a false positive result. So you want that p-value to be as low as possible because you want as low a chance as possible that your results were just a false positive. And that's what that significance level or alpha level or p-value represents. And typically in the social sciences, we set that cutoff to 0.05, and that corresponds to a false positive rate of 5%. So what we're saying with that 0.05 is that we want there to be no greater than a 5% chance that the result that we get in our study is a false positive. So if that p-value that we get is below that 0.05, it means that there is less than a 5% chance that it's a false positive result. And so that is strong enough evidence for us to reject the null hypothesis and say that there are differences between groups, or that correlation is significant, whatever the test you're running may be. So that's kind of the general logic behind how we use the p-values to determine if we should accept or reject or a null hypothesis, or rather reject or fail to reject a null hypothesis. Okay, so I'll just wait another minute or so to see if there are any other questions that come in. Okay, so it doesn't look like I have any more questions in the queue right now, or I have one more question. So how should research questions be stated? Um, so it really depends on how or what um, types of tests you're doing. So in general, with a quantitative study, um, research questions should be stated such that the answer or it can be answered with a yes or no, because that's kind of the nature of the tests that you're doing, is that you come up with kind of a black and white or yes or no answer based on that null hypothesis testing that we were just talking about. So for instance, if you're doing relationships between variables, like a correlation, your research question might read something like, is there a relationship between, you know, transformational leadership and employee satisfaction? Um, that's worded in such a way that you can answer that with a yes or a no. Yes, there is a relationship, or no, there is not a relationship. If you're doing something like comparing groups or t-test, you can word it like, you know, is there a difference um, between males and females in their self-efficacy scores? You can answer that with a yes or a no. Is there a difference? Or yes, there's a difference. No, there's not a difference. So that's generally how research questions um, should be constructed. Um, but if you want more information or guidance specifically on creating research questions, we do have other webinars that go into that topic in more detail. So you can look out for our other webinars, past webinars that we've done that have focused on constructing the research questions, and that may give you a little bit more information. Right. It looks like that is the end of the questions now. So I will go ahead and end our session here for today. And again, if you are interested in additional support, you can use the information that we have here to contact us for more one-on-one support. Or like I said before, you can look at our other webinars on other topics in case you're interested in those. Um, but otherwise, thanks everyone for attending today. I hope everyone found this useful, and I hope everyone has a great day.